Welcome to the Baboom Baboom podcast, your go-to source for expert tips on car stereo installation, vehicle wiring, and all things wiring related. Whether you're a seasoned pro or just getting started, we've got the advice to help you power up your ride. Get ready to crank up the volume on your knowledge and make your next wiring project a success.
Hey everyone, welcome to another deep dive. Today we're going to be getting into something that's surprisingly interesting, AC/DC power. And no, before you crank up your stereos, we won't be diving into the music of the legendary band, though I wouldn't mind a little Hell's Bells right now.
Right.
We're going to be tackling the electrifying world of AC and DC electricity, the forces that power our world, based on this really informative article from Baboom Baboom.
Okay. Sounds good.
Get ready to amp up your knowledge, everyone, because this is going to be electric. So when we talk about AC/DC, what comes to mind? What's the first thing you think of?
Well, what's really cool about this topic is how we're interacting with both AC and DC power constantly every single day, and most of us don't even realize it.
It really is. It's like this hidden language, right? Like we just hit a switch and boom, the lights are on. But how many of us actually stop and think, wow, the magic of alternating current?
Exactly.
So let's break it down, shall we? For those who might not be familiar, what exactly are we talking about when we say AC and DC?
Well, AC stands for alternating current. Imagine like a river that's changing its flow, going back and forth, reversing direction periodically.
Okay.
That's basically what the electrons, those tiny little charge carriers, are doing in AC. They're shifting back and forth.
So they're like playing a never-ending game of electron ping pong.
Yeah, you could say that.
Okay, I like it. And then on the flip side, we've got DC.
Exactly. DC, or direct current.
And this one's more of a straight shooter.
Yeah. In DC, those electrons are on like a one-way street, just flowing steadily from a point of higher potential to a point of lower potential.
So AC is the indecisive one, always changing its mind, while DC is like, I've got a plan, and I'm sticking to it.
Exactly. You got it.
It's fascinating, this whole idea of electrons bouncing around or flowing like a river. But how does this translate to the real world? Why is AC the go-to for powering our homes? Wouldn't that consistent DC flow be smoother, less chaotic?
Yeah, that's a great question. And the reason for that is all about AC's ability to easily transform its voltage.
Okay, hold on. Voltage. Can we rewind a bit? What exactly are we talking about when we say voltage, and why is changing it up so important?
Yeah, of course. So think of voltage kind of like the pressure pushing those electrons along the wire.
Got it.
Higher voltage, more pressure, lower voltage, less pressure.
Okay, that makes sense.
And here's where AC's transformative ability really comes in handy. It can easily have its voltage what's called stepped up, meaning increased, or stepped down, decreased, using transformers. And this little trick is super important for long-distance transmission, getting that power from the source to your home.
I'm already sensing an aha moment coming on. Do tell.
So picture this. You've got power plants, right? They're generating electricity.
Right.
But these power plants are often located pretty far away from where that electricity is actually needed, like our homes and businesses.
Makes sense. Got to keep those power plants at a safe distance.
Exactly. Now, here's the thing. When you're transporting electricity over long distances, you want to make sure you're not losing too much energy along the way, right? It's like sending a package.
You want it to arrive in one piece.
Precisely. So to cut down on that energy loss, those clever folks at the power plant use transformers to do what?
Step up the voltage.
You got it. They step up the voltage of AC electricity to these incredibly high levels.
Wow.
And this high voltage allows the electricity to travel super efficiently through those power lines, minimizing those energy losses on its journey to us.
So it's like sending those electrons on a high-speed train across the country and then having them slow down as they approach a station.
Exactly. You got it.
I love it when a plan comes together.
Yeah.
So high voltage for the long haul, then step it down as we get closer to home. Makes perfect sense. Now, while we're on the topic of AC, there's this thing I've always wondered about frequency.
Okay.
This article mentions that the AC electricity in North America has this frequency of 60 hertz. What does that even mean, 60 hertz?
So that means that the current changes direction. Remember those electrons doing their little back and forth dance?
Yep.
60 hertz means they're changing directions 60 times every single second.
60 times a second.
That's insane.
Yeah.
Is there like a reason we landed on 60 hertz? Why not 50 or 100? Was it just a random dart throw?
That's a great question, and it's a lot more than just a random number, right? This goes back to the early days of electrical systems.
Need top-quality electrical wire? Baboom Baboom's got you covered. Get your 6-pack today. Each combo comes in 6 different colors and a total of 600 feet of wire. Perfect for any project, and you won't find a better price in the industry. Head over to baboombaboom.com now to snag yours. That's baboombaboom.com.
Where engineers were trying out different frequencies.
Oh, interesting.
And it turned out that 60 hertz kind of hit a sweet spot. It balanced the efficiency of how the power was generated and transmitted with how well electrical devices actually performed.
It's all about finding that rhythm, huh? Getting everyone moving and grooving at the right tempo. But while AC might be the life of the party when it comes to our electrical grid, I'm sensing that DC has its own fan club.
It does.
In fact, I'd bet good money that DC is powering a lot of the devices that we rely on every single day, right?
Absolutely. You are right on the money with that one. We're talking about everything from your phone to that big, beautiful flat screen TV you've got. They all rely on DC power. Okay, now that's interesting. I thought we just established that AC is the rock star of power delivery, the one that can travel those long distances. What's the deal with our electronics being so into DC?
You got it. Your phone, your TV, pretty much any gadget you can think of, they all love that DC power.
They do, huh?
Yeah.
Well, that's kind of surprising to me. I mean, we just spent this whole time talking about how AC is the one that can travel all those crazy distances, right? What's the reason our electronics are so into DC?
Well, think about it this way. AC is like the long-haul trucker of the electricity world. Great for those long journeys. But when it comes to the delicate circuitry inside our gadgets, they need something a little more, well, stable. And that's where DC shines. That nice, consistent flow is what our electronics need to thrive.
So my phone is basically like a picky eater, only wants that smooth, clean DC energy. Okay, I can dig it. But how does this whole conversion thing actually work? I mean, we're plugging our devices into those AC outlets in the wall, right?
Right. Most electronic devices these days have this really clever bit of circuitry built right in. It's called a rectifier. And its whole job in life is to take that AC power from the wall and turn it into that smooth, stable DC power that your gadgets crave.
So it's like a translator, making sure the incoming energy speaks the right language for my phone. I like it.
Exactly.
Yeah.
It's all about making sure that energy is in the right form, the right voltage for your specific device.
Speaking of voltage and conversion, I've always been curious about those bulky adapters that we often need for our electronics, like the one for my laptop. What's the deal with those?
Those adapters, those are like mini rectifiers on the go. They're doing the same important job of converting that AC power from the wall, but specifically tailored for your laptop's needs. They're making sure it's getting the exact right voltage it needs to function properly.
So it's like having a personal chef for your laptop, making sure it gets that perfectly prepared meal.
Exactly. It's all about precision. Now, we've talked a lot about AC powering our homes and DC being the go-to for our electronics. But what about other applications? This article got me thinking about solar panels, which always scream clean energy to me.
Yeah.
Where do they fit into this whole AC-DC story?
That's a great question. Because when I think about solar panels, I think about the future of energy, right? Sustainable, renewable, all that good stuff. But how does it actually work on a practical level? I mean, if our homes are primarily running on AC and solar panels are, well, out there soaking up the sun's rays, how does that all connect?
You're hitting on a really crucial point. It's like we've got these two different worlds, right? AC land and DC land, and someone's got to build a bridge between them, and that's where inverters come in.
Inverters. Okay, I'm intrigued. Tell me more.
So solar panels, those amazing little energy collectors, they actually generate DC power.
They do. Okay, so we've got DC power coming from the sun, and we need AC power to keep our homes humming along. What happens next?
That's where the inverters step up to the plate. Their whole job is to take that DC power generated by your solar panels and transform it, convert it into AC power. And once it's in that AC form, it can be used in your home, no problem, or even cooler, could be sent back to the electrical grid.
Whoa, back to the grid. So my rooftop solar panels could actually be powering my neighbor's house. That's amazing. But it still feels like we're jumping through hoops here, right?
Yeah.
Converting DC to AC and then maybe back to DC again. It's like a game of energy tag. It makes you wonder, with all these advancements in technology, especially with things like electric vehicles becoming more and more common, could we ever see a world where DC power plays a bigger role? Maybe even a DC-powered future? What are your thoughts on that?
That's $1 million question, right? DC-powered future. It's definitely a hot topic in the energy world these days.
It is. I mean, think about it. Electric cars, they run on batteries, right?
Right. Big, powerful batteries.
And batteries are all about that DC life. So are we headed toward a major shift in how we power our world?
It's definitely a possibility. While our current electrical grid, the one we've been talking about this whole time, it's built on AC. But with more and more devices going the DC route and renewable energy sources like solar becoming more popular, there's a growing conversation about whether a more DC-centric future might be on the horizon.
Okay, now we're talking. A DC-powered future.
Hmm.
But what would that even look like? I mean, would we need to completely revamp our entire electrical grid, rip it all up and start from scratch?
Yeah.
That seems like a pretty daunting task. It's a
Yeah.
massive project, right? Like swapping out the engine of a car while it's still running. But it does make you think, with more and more things going the DC route, like you were saying, and with renewable energy sources like solar becoming more and more common, is it possible that we're headed for a major power grid makeover sometime soon?
It's a question a lot of people are asking. A lot of really smart people are working on a complete overhaul of the grid we have now. That's a huge job, for sure.
Right.
But there are people out there doing a ton of research on how to integrate more DC infrastructure into what we already have, especially when it comes to things like charging electric vehicles, managing power from solar panels, that sort of thing. Some experts think that microgrids, these smaller scale DC-based grids, could be a big part of a future powered by renewable energy.
Microgrids, huh? So like little pockets of DC power.
Exactly. Imagine like neighborhoods powered by a network of solar panels and batteries, all humming along on DC power.
Okay, that does sound pretty futuristic. Homes basically becoming their own little power stations.
Right.
So what would be the advantage of these microgrids if we did move towards a more DC-powered future?
Well, one big advantage is that they could potentially cut down on the energy loss that happens when you have to convert AC to DC, like we were talking about before.
Ah, right. Because if everything's already running on DC,
Exactly. You cut out the middleman.
makes sense.
Plus, they give you more flexibility when it comes to using renewable energy sources, since a lot of those naturally generate DC power.
Oh, that's a really good point. So it's like
Right.
we're not just changing the type of power, we're changing the whole system.
Exactly. It's a whole new way of thinking about how we get electricity.
It's pretty mind-blowing when you think about it, this whole invisible world of AC and DC power humming along all around us.
It really is.
I mean, we flip the switch, the lights come on, we charge our phones without even thinking about it. But behind the scenes, there's this whole intricate dance of electrons and currents and conversions happening.
Absolutely. It's easy to forget about, but it's what makes everything work.
It really is. Well, I gotta say, this deep dive has been a real eye-opener for me. We've gone from the basics of what AC and DC even are to talking about the future of power grids and microgrids and renewable energy.
It's been a fun one.
It has. And I think the biggest takeaway for me is just how much we take for granted when it comes to electricity.
Yeah,
It's just always there, right? But there's so much more to it than meets the eye.
there really is.
So I think next time I plug in my phone or turn on the lights, I'm going to take a second to appreciate the amazing, invisible world of AC and DC power that's making it all happen.
I think that's a great idea.
Well, that about wraps things up for this deep dive into the world of AC/DC power. For the deep dive, I'm your host, signing off. Thanks for joining us, everyone, and keep those brains buzzing.
Need top-quality electrical wire? Baboom Baboom's got you covered. Get your 6-pack today. Each combo comes in 6 different colors and a total of 600 feet of wire. Perfect for any project, and you won't find a better price in the industry. Head over to baboombaboom.com now to snag yours. That's baboombaboom.com.